so don't say anything that you don't want recorded forever. We're starting today kind of our unit on functions, which you did an intro activity to on last Friday. So our first learning target is just that we can identify functions. We've already practiced that a bunch. We're going to start with just some few definitions. So the first one is just like what a function is. And all a function does is really pairs an input. You put something into the machine, and then we go through what we call our function rule, and it outputs something from the machine. So there's an input and an output. Though those inputs and outputs, we can call those ordered pairs, where any value that we plug in for x is an input, and y's are always our output values. So we think when we label points in math, it's x comma y, where x and y are numbers, so it could be like 2 comma 1. That would be 2 would be our input. We plug 2 into the machine does something, and it spits out a 1. Remember, if you ever struggle with what is a function, or kind of like, what's the process behind it, what makes something a function, think of a vending machine. If I hit 2 on the vending machine, I expect to get out the same output each time. I expect to get out a 1. Each time I hit 2 on the vending machine, I get out a 1. That is a function. If I punch a 2 on the vending machine and I get a 1 sometimes and a 4 other times, that's not a function, because each input does not have exactly one output. And that's that definition, kind of our last bullet point here. A relation is a function. So a relation is just how things, go together. It is a function if each input has exactly one, and that's the two key words, exactly one output. So if it has 2 outputs, no longer a function. If it doesn't have an output at all, also not a function. So we're going to go through just a few examples and determine whether these relations are functions or not, and we're just going to do brief explanations. So the first one, we have a bunch of points. And these points, we call them ordered pairs, because we could say all of these are x and y values. So this could be an x value, that could be a y value. All right, because they use that x comma y. I think the best way to figure out if something is a function when you're giving points is we call it a map. So I'm going to take all of the x values, so that's all the numbers that come first, and I'm going to put them kind of in a little box on one side. And I'm going to label the top x, and x's are always inputs, so we're going to try to remember that. And I'm just going to list them all. -2, -1, 0, 1, and 2. I'm going to do the same thing, but now with my y values, which are my outputs. So I'm going to put all of these folks in their own box as well, just kind of next to it. We're going to say these are our y values, or our outputs. I'm going to list them all. It was 2, another 2, another 2, 0, and 0. And now this is why we call it a map, because we're going to map each input to its corresponding output. So when I hit -2 on the vending machine, I get out a 2. So I'm going to draw an arrow from -2 to this 2, because I plug that in, I get something else out. If I plug in -1, I also get out a 2. If I plug in a 0, I get out a 2. If I plug in a 1, I get out a 0. and 2, I get a 0. So we notice that each input is mapped, or there's an arrow going to exactly one output. So we know, yes, this is a function because it meets kind of the criteria. Each time we press a unique button, a unique input on our vending machine, we get a unique output. So to explain, it could just be short. You could say yes, comma, and then your explanation, you could just kind of say, okay, state the definition. Each input, bless you, has, and then we're going to use exactly one because that's the definition. Output. This is something you saw when you're doing that Desmos activity. You saw an example like this, where you had points and you were figuring out whether or not it was a function. If, like in example B, if our inputs and outputs or our x and y values are given to us in a table, we could do kind of the mapping is already kind of set up for us. When we input a -2, we get out a 3. When we input a -1, we get out a 4. When we input a 0, we get out a 5. When we input a 0, we could also get out a 6. So we could have this right here. We could stop because this piece right here breaks the rule of what a function is. Because 0 does not have exactly one output. 0 has 2 outputs. If I put 0 on my vending machine, I could get out a 5 or I could get out a 6. So to explain whether this would be a function or not, we could say no. And then we want to give a reason as to why to support or justify. We could just say 0 has 2 outputs. Remember, that's why it's in the definition. It says exactly 1. No more, no less. This is kind of example C is another way to look at kind of our mapping structure. So we see -1 goes to 4, 3 goes to 15, and 11 goes to 15. This is just a slightly different from the mapping I drew up top. So I would have, if I was doing it, I drew mine like, okay, well, 11 has its own 15. This still is a function because each input has exactly one output. 3 goes to 15, 11 goes to 15. 3 and 11 are different inputs, so it's still okay that they go to the same output. All right? 3 still has exactly one output, 11 still has exactly one output. They just happen to be the same. So if we were going to write this, we would say yes. And then we use kind of the same wording we used for that example A. Each input has exactly one output. So if you can kind of just, you could use that each time something is a function. You could just use this phrase here. You don't have to make up your own phrase. You could just take this word for word, because we're just matching the definition of a function. All right. One other way to determine whether something is a function or not is what we call the vertical line test. So what this says is a graph represents a function when no vertical line passes through no more than 1 point on the graph. So think about like when we use inequalities, no more than means it could be 1 exactly and anything less. All right? You sit in that back corner there. I'll grab you a note sheet. So, why this vertical test works. If we look at example 2a, remember vertical, something vertical goes up and down, top to bottom. So we're looking at this graph here. If I draw a vertical line, I like to do when I'm doing my vertical line test, I like to make little dash lines. I draw a vertical line up and down. It only crosses that 1 point right there. All right, so far, just having drawn one line, we could say, all right, well, this could be a function. We can't make a conclusion yet. If I move one box over, do another little dash line down, I cross 2 points. The 2 points that I cross, if you label them, kind of using our x comma y, our x value again goes horizontally, so this would be 2 comma 2. And this point would be 2 comma 5. So when you label your points, you can see why the vertical line test works. Because if we were to draw a little map of our inputs and outputs, 2 can go to 2 or it can go to 5. So this fails the vertical line test because 2, the number 2, has 2 different outputs. So you could say it fails the vertical line test, or no, it's not a function. And then I'll just say, because if we're using the vertical line test, that's enough to use in our explanation. We could say it fails the vertical line test. And I know that's a lot to write, so you can abbreviate it as VLT. I don't even have to check over here. It would fail it if I was to draw a vertical line down this way too. But once it fails once, it's always going to fail. All right. So we look at just B. And the key point with the vertical line test is that you should be able to draw a vertical line anywhere on your graph, not just on kind of your grid lines. And it should only ever cross your graph once. And that's the case here. It only crosses once, 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 once. So that's saying for each x value that I plug in, each value here on the bottom, I'm getting a different y value. Which makes sense because it's going up. We call that a linear function. Linear meaning line. So for an explanation, we could say yes. And why? Because it passes the, then we'll use our abbreviation VLT.